Good morning everyone. Welcome to today's maths class. Today we are going to learn the trigonometric identities. What is an identity? Let us recall the definition of an identity. An equation is called an identity when it is true for all values of variables involved in it. Okay. Now let us derive some identities in the trigonometry. Okay. For that let us have a right angle triangle ABC in which angle B is 90 degrees. And let us take this angle C, acute angle C as theta. Okay. Now in triangle ABC, angle B is equal to 90 degrees and angle C is equal to theta, where 0 degrees less than theta less than 90 degrees. Means here theta is an acute angle. Okay. Now by applying Pythagoras theorem, we get AC square is equal to AB square plus BC square. The square and the hypotenuse is equal to sum of the squares of the other two sides. Okay, in a right angle triangle. Now let us write the same equation in another form. AB square plus BC square is equal to AC square. Okay, now let us divide this entire equation with AC square. Now divide with AC square. Each and every term should be divided with AC square. BC square by AC square is equal to AC square by AC square. Now AB square by AC square can be written as AB by AC whole square. BC square by AC square can be written as BC by AC whole square. And here in this fraction AC square, numerator, denominator both are same. So we can cancel them and then we get 1. Now look at this. Now with respect to this theta, what is AB by AC? AB is the opposite side of this theta and AC is the hypotenuse. So AB by AC is opposite side by hypotenuse. The opposite side by hypotenuse is the ratio of sine. So AB by AC whole square can be written as sine square theta. And BC by AC, BC is the adjacent side and AC is the hypotenuse. So BC by AC can be written as cos theta. So BC by AC whole square is cos square theta is equal to 1. This is the first identity of trigonometry. Now for the second identity, divide this entire equation with the BC square. Now we get AB square by BC square plus BC square by BC square is equal to AC square by BC square. Now we can write AB by BC whole square, BC square can be cancelled, AC square by BC square can be written as AC by BC whole square. Now look at this. What is AB by BC? Opposite side by adjacent side. We can write it as tan theta. So tan square theta plus 1 is equal to AC by BC. Hypotenuse by adjacent side can be written as secant theta. Here there is square. So we can write it as secant square theta. Now this is the second identity actually. We can write this identity in the another form. Now that is secant square theta minus tan square theta is equal to 1. This is the second identity. Now for the third identity, let us divide this equation with AB square. Now AB square by AB square plus BC square by AB square is equal to AC square by AB square. Now AB square can be cancelled. 1 BC square by AB square can be written as BC by AB whole square. AC square by AB square can be written as AC by AB whole square. Now 1 plus BC by AB, adjacent side by opposite side, can be written as cot. So as there is square, we can write it as cot square theta. AC by AB, hypotenuse by opposite side, can be written as cosecant. So as there is square, we can write it as cosecant square theta. So 1 plus cot square theta is equal to cosecant square theta is the third identity. Now this identity can be written in the other form, that is cosecant square theta minus cot square theta is equal to 1. Okay? These are the three identities. Let us list out all the three identities once again. The first identity is sine square theta plus cos square theta is equal to 1. The second one is secant square theta minus tan square theta is equal to 1. And the third one is cosecant square theta minus cot square theta is equal to 1. These are the three trigonometric identities. These are very important, and by using these three identities we can solve the problems from the exercise 8.4. Now first problem from the exercise 8.4. Now express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Okay? Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. So let us do this problem with the help of identities which we have proved. Now, first of all, sin A. Sin A can be written as 1 by cosecant A. Why? Because sine and cosecant are the reciprocals of each other. Now, we have an identity, the third identity which we have proved is cosecant square A minus cot square A is equal to 1. Now from this what you can write? Cosecant square A is equal to 1 minus cot square A. If you sine to RHS, we will get 1 plus cot square A. Okay? So cosecant square A can be written as 1 plus cot square A. Now this implies cosecant A. If you want cosecant A, we need to remove the square in the LHS, then we get root in the RHS. Cosecant A is equal to root over 1 plus cot square A. So this can be written as 1 by, this cosecant A can be written as root over 1 plus cot square A. Okay? Now, sin A, we have changed it into the terms of cot A. Now, let us do the second one, secant A. How can you convert secant A into the terms of cot A? Now, secant A can be written as, now let us go with the second identity. What is the second identity? Secant square A minus tan square A is equal to 1. Actually, while we were proving the identities, we have taken the acute angle as theta. We can take any variable in the place of theta. That's why we have taken secant square A minus tan square A is equal to 1. From this we can write secant square A is equal to 1 minus tan square A can be taken as plus tan square A. Now secant A is equal to root over 1 plus tan square A. By using this one, we can write it as 1 plus tan square A. Now root over 1 plus, what is tan? Tan is the reciprocal of cot. So tan square A can be written as 1 plus 1 by cot square A. Now this is equal to square root of cot square A into 1. Cot square A plus 1 by cot square A. This is the value of secant A in terms of cot A. Now, next. Now tan A. Tan A we have to change into the terms of cot A. Now tan A, we know that tan is the reciprocal of cot. So tan A can be written as 1 by cot A. Now look at this, sin A, secant A and tan A. We have converted into the terms of cot A. So sin A is equal to 1 by root over 1 plus cot square A, and secant A can be written as root over 1 plus cot square A by cot square A, and tan A can be written as 1 by cot A. Now look at the second problem. Write all the other trigonometric ratios of angle A in terms of secant A. Okay. Now, what are the trigonometric ratios? First, sin A. How can you write sin in terms of secant? First of all, what is the identity in which the sin is involved? Sin square theta plus cos square theta is equal to 1. The first identity. From this we can write sin square theta is equal to, if you take the cos square theta into RHS, we get 1 minus cos square theta. Then sin theta is equal to square root of 1 minus cos square theta. So from this we can write sin A is equal to square root of 1 minus cos square A. So instead of A, we have taken theta. So theta can be replaced by A. Now, is equal to square root of 1 minus cos is the reciprocal of secant. So cos square A can be written as 1 by secant square A. Now this is equal to square root of secant square A into 1 is secant square A minus 1 by secant square A. Okay. Now root over secant square A minus 1 by, in the denominator square and root will be cancelled. Secant square A, root over secant square A. This can be written as root over secant square A minus 1 by, square root will be cancelled, in the denominator we get secant A. So the value of sin A in terms of secant A. Now let us convert cos A in terms of secant A. Now how can you write? What is the reciprocal of cos? The reciprocal of cos is secant. So we can write directly cos A as 1 by secant A. Okay. Now, how can you convert tan in terms of secant? Now, tan A is equal to, tan A can be written as, what is the second identity? Secant square A minus tan square A is equal to 1. From this we can write secant square A, this 1 you can take to LHS, and minus tan square A can be taken to RHS. From this we will get, just by reversing this, we get tan square A is equal to secant square A minus 1. Then what is tan A? If you remove the square in the LHS, we get root in the RHS. So here tan A can be written as root over secant square A minus 1. Root over secant square A minus 1. Next, what is the next trigonometric ratio? Here we have converted sin into the terms of secant, cos into the terms of secant, tan also in terms of secant. What is left over? Then cot can be written as 1 by tan A. Already we have converted tan into the terms of secant, that we can replace in this 1 by tan A can be written as root over secant square A minus 1.